Okay, before these questions, what is optics, by the way? Tell me about optics. What is optics? Today we'll do everything, revise everything about optics. Quick revision. Yes, people. What do you mean by optics? You're studying 10th standard, 12th standard, 11th standard. Do you remember? Yeah. Right here. Study of nature, how light travels. Simple. Study of nature of light, how it travels, how it behaves, how it propagates. That's it. That's optics. Now, in that we have two types, ray and wave. Ray optics deals with what? Particles of that light. Simple. And wave, how it moves. Ray optics deals with particles, particle nature. Wave optics what it do? It consider this as a light as a particle or wave nature. Laws of reflection, you remember? I angle I equals to angle R. And all three are normal incident, normal incident, reflected rays are in same plane. Okay, let's share this page itself, so it will be easy to discuss. Wait, let me open it. Okay. Okay. Finish. Wait. Okay. So reflection of light, what? Angle of light, angle of incident, and angle of reflection are in same, right? And incident and reflected are in same plane. They both are same and both are in same plane. No change in wavelength and frequency. These are quick study material. If you want, I can share this one also. It won't be in detail, but just quick study material. for quick exam. Like we have exam next month, so for that. Now spherical mirror, we have in that we have convex and concave. What are they? Outer bulging, inside bulging, reflecting here. So this side is silvered part, and this is reflecting sides. So what are the rules here? Array parallel to principal axis, pass through focus, and array incoming to the point pole. It's the same way. It's passed through same manner with making same angle. Making same angle. Formulas: 1 by f equals to 1 by v plus 1 by u. U is object distance, image distance. What is sign convention? Left side negative, right side positive. So m equals to height of image by height of object, high by ho. Easy to remember. So which is minus v by u. Focal length is half of radius, right? These things we know. Laws of reflection. Snell's law, sin I by sin r, which is constant, which is refractive index, medium 2 by medium 1. And n is the absolute refractive index. When we are taking absolute refractive index, when one medium is constant, like the standard medium, which is air or vacuum. Refractive index, speed of light in vacuum by speed of light in some other medium. Formation of image due to refraction. This is very important. This thing you know till here. Okay. According to Snell's law, N2 medium. What is N2 medium here? Is more than N1. The refractive index of 2 is more than 1. So angle I is more than angle R. That is, the ray of light enters from the rarer medium to denser medium. So this is air is rarer medium through glass, water. Or let's take this as a glass. And again, air. This one, there are 3 mediums: air, water, and glass. It is okay. So what will happen here? It is deviated towards the normal. If the ray of light enters from the denser to the rarer medium, it is deviated away from the normal. It's very simple. Towards the normal, away the normal. Ray of light, this is what? Rarer to denser. It moves towards the normal. And normal is here, away from the normal. So this distance is lateral displacement. Okay. So if this is apparent shift, real depth by apparent depth. So L is the real depth where it is kept. It assumes its visible is as x distance away from it. So this apparent depth, real depth minus x. L by L minus x. Real depth minus apparent position. That is your apparent position. Now refractive index through number of medium means many medium. 1, 2, 3. There are 3 mediums here. 1, 2, and 3. So consider a refraction of ray of light through series of medium as shown in figure. The ray AB is incident on air, water. Now we are starting with air and water. Air and water. So rarer to denser, denser to rarer, right? Rarer to denser, denser to rarer. Rarer to denser, towards, away. It moves towards the normal. See, this should be actual line. It's moving towards. Again, it's moving towards. Now, denser to rarer, so it's moving away. It's moving away. That's what we are doing here. Sin I by sin R for first. Then second, sin R as sin this reflected ray will be incident for second medium. This one and third one. There are 3 times refraction is happening here. Change of media. First one, air to water. Second time, water to glass. And third time, glass to air. It is 3 times happening. So we have 1, 2, and 3 media. 3 refractive index here. Now this is the next important thing. Critical angle. When ray of light incident on the interface from denser medium to rarer medium. When a ray of light interface from denser to rarer medium, it is deviated away from the normal. Okay. When the angle of deviation is increased, the angle of refraction also increase, and a straight becomes, at that stage it will become 90 degree. So angle of incident is denser in a denser medium, for which the angle of refraction in rarer medium is 90 degree. That is called critical angle, because after that there will be total internal reflection. It will start reflecting inside. It will not exit. Here rays are exiting, right? Here rays are exiting from one medium to another medium. It will keep on reflecting inside. That's what it is used. Some place it is good, some place it is not good. Depends where we required and what is the requirement. Yes, Zahiya, are you able to understand? You know this, right?
Yes, sir.
Then total internal reflection. When angle of incident in the denser medium is greater than the critical angle, the incident ray does not reflect into rarer medium, but reflect back into denser medium. That is, keep on reflecting here. This is called total internal reflection. Now, what are the conditions? The ray must travel from denser to rarer. The angle of incidence should be more than critical angle. Angle of incidence should be more than critical angle. So critical angle for air, glass, air, sorry, water, air, glass, air, diamond, air is 49, 42, 24. These are some standard critical angles for the standard things. Diamond, glass, and water. For water, it's 49. For glass, it's 42. For diamond, is 24. Standard values. Spherical lens. Rules to form, it's very easy. You have studied lower standard. Ray parallel to principal axis, pass through focus, passing from optical center, does not deviate from focus, it will become parallel. So image is formed same manner, appears to pass through focus. These are easy. Thin lens. One by f equals to 1 by v plus 1 by u. Okay. So this is important. This you know already till here. Till here, everything you know. But you need to remember now this one also. Lens maker. 1 by f equals to refractive index minus 1. 1 by R1 plus 1 by R2. Okay. N12 is refractive index of material with lens with respect to surrounding medium. So from 1 to 2. So refractive index of, remember like this, n minus 1 into 1 by R plus 1 by R2. Next is power of lens. P equals to 1 by F. Don't forget to convert it into meters. Unit is diopter. Okay. Okay. Lens immersed in a liquid. So it will be changed in media, simple. The refractive index will be differing because we are keeping inside some liquid. So 1 by F equals to N some liquid minus 1. Again, formula is same, 1 by R1 minus 1 by R2. This formula is same. What is changing? Only this one. If Ng for glass and liquid, they are changing. From one medium to other medium is changing. There are two medias here. It's more than one. So this medium is more than another medium. Okay. So that the nature of lens remain unchanged, but focal length increase. Hence, power of lens decrease because P equals to 1 by F. Here we wrote. In other words, converging lens becomes less converging, and diverging lens becomes less diverging. So it diverge less, converge less. So if it is a thin lens, it will behave as a plane. Like if n and both are equal, so f will be infinity. That is, lens behave as a glass plane, because plane mirror or plane glass have infinite focus. Area? Am I going fast, or are you able to understand? You know all this? See, I'm just revising for you so that you can recall everything. The idea? Are you there?
Yes, sir.
Do you know all this? Do you remember? Okay, just next is thin lens. So 1 by focus, that is power. So we can add those P plus 1, P1 plus P2 plus P3, power of combination of lens. Combination of lens in a mirror, the arrangement of lens and mirror, that the object we place in front of lens, incident ray from the object first undergoes refraction at lens and then incident at the mirror to obtain a position of image. To combination of how to form this. First, using refraction formula, we can calculate where image would be formed. Had there would be a one lens, we then consider this image as an object from the mirror. So in lens, suppose image is formed here. So we'll place this mirror nearby and we'll assume this as an object. The image formed this as an object and will form again. The mirror formula, we can then locate the position of final image formed by the mirror. Then final position would be position of the image due to combined effect of refraction at the lens and reflection at the mirror. Refraction at lens and reflection at the mirror. In prism, it's very easy, this one also. It's what same thing is happening, changing of media. Rarer to denser, denser to rarer. So minimum deviation, the reflected ray within a prism is parallel to the base. Minimum deviation is parallel to the base. So I1 equals to I2. Now you can see here. Now is it visible? I1 and I2. Very simple. I1 and I2 are same, then that means R1 and R2 is also same. So R2R plus equals to A equals to R by 2, this point. So I plus I equals to A plus delta M. Why is delta M here? Okay. So A plus delta M by 2. I equals to A plus delta M by 2. So sin I by sin R, I equals to A plus delta M by 2, and sin R is A by 2. So delta M equals to n minus 1 by into A, not by. So for thin prism, A is less than 10 degree. A is that corner point, angle of prism. A is angle of prism. Scattering of light. A light is scattered by air molecules according to Relay. So intensity of scattered light is inversely proportional to 4 times of wavelength. Wavelength to the power 4, not 4 times. So deviation of red, red is more than blue scattering. Lambda is wavelength of red is more than blue. That is obvious. BI BGYO. Highest wavelength, lowest the deviation. This is lowest wavelength, higher the deviation. Now, optical instrument. Simple microscope. It consists of convex lens of small focal length. Beta is the angle subtended by an eye. Alpha is the angle subtended by an object. This is for beta is for image, alpha is for object. Distribution is D. Magnifying power is this one. Beta by alpha equals to D by V, 1 minus V by F. So if the image is at infinity, V also infinity, then M equals to D by F. If the final image is at distance and distance vision, so V equals to D. So M equals to 1 plus D by F. Instead of V, we'll write D by F. Compound microscope. A compound microscope essentially consists of 2 coaxial convex lenses of small focal length. So there are 2 lenses. The lens facing the object is called objective lens. While the eye is called eyepiece, from where we are looking for our vision. So magnifying power, it is equals to m equals to beta by alpha. So that's what we wrote here, Vd by Ve. Separation between two lenses, V0 plus UE. Some special case for that. When final image is formed at a distance of distance vision, DE equals to D. So M equals to PD, the previous formula. L equals to V0 plus UE. Same with the distance between second focal point of objective and first focal point of eye lens is called tube length. That is L. So V0 by U0 equals to L by F0. And final image is formed at infinity. So V equals to infinity. Same with the same formula. You're writing V0 by U0 equals to, sorry, into D by FE. Telescope, it is an optical instrument used to see distant objects. So what is the work of this one? So we can see infinity object. Object is an infinity, we can see it. Or when image is at infinity, we can locate. Okay.